Hello, class. I am going to help you with your pH problems. Let's first address problem 1 and 2. 10 to the negative 9.3 can also be written as 1 times 10 to the negative 9.3. If you were to take the negative log of this number, you would get 9.3. In other words, all you have to do is use this superscript and take the negative of this negative 9.3. But what if you aren't comfortable with that? If you didn't realize that this is already 1 times 10 to the negative 9.3? What if you wanted to enter that number into your calculator? Well, on your calculator, you have this button called X to the unknown power. On a Texas Instrument calculator, it's probably X to the Y button. If I select that button, I then enter my base unit 10. Then I scroll over to the exponent. I use my negative sign. Do not use your subtraction sign. You have a negative sign on your scientific calculator. And I enter 9.3. Then this gives me my number in moles per liter, an expanded number. I'm going to save that number by hitting the answer button. Now I take the negative log, and I put in my answer. I close my parentheses, and I get 9.3. You would do the same thing, for problem number 2. Now, what about problems 3 and 4? Well, they are in standard notation, but the units are still fine. So put your standard notation into scientific notation. And you would get 1 times 10 to the negative 6. The pH of that, the negative log of 1 times 10 to the negative 6, is 6. And then over here, again, you would put this in scientific notation, and you would get 3.02 times 10 to the negative 6. 1, 2, 3, 4, 5, 6. 3.02 times 10 to the negative 6. How do I put that in my calculator? Again, I hit the negative sign, then log 3.02 times 10. I hit my negative sign to the negative 6, close parentheses, and I get 5.52 for a pH. All right, well, question number 5. It already has the correct units. It's already in scientific notation. You just put that in your calculator. You hit the negative log, enter 9.1 times 10 to the negative 7. And again, most of you are going to see this times 10 to the x, which means you're playing with the base 10, and the x, you fill in the superscripted number. In this case, it would be negative 7. So the negative log of 9.1, the negative log of 9.1, it's hard to do this through the camera here, times 10, again, my negative value, my negative sign, don't use subtraction, close my parentheses, and I get 6.04 as a pH. Our last problem is this one, 0.05 microequivalents per liter. Well, first of all, this is not in moles per liter. So the question is, what is an equivalent? An equivalent is another way of saying, well, it's another way of saying concentration. And instead of saying moles per liter, an equivalent is saying, how many moles of charge do you have? Well, hydrogen, the hydrogen ion, which is what we're dealing with when we're talking about pH, has a +1 charge. So if you have 1 mole of hydrogen, you would have 1 mole of positive charges. Because it is a 1-to-1 ratio, you can substitute 0.05 microequivalent is the same as 0.05 micromolar. It's a 1-to-1 exchange. So if you ever see equivalent and you're playing with hydrogen, you can change that letter E into an M. And now we know we have 0.05 micromolar. Well, how do I convert micromolar to molar? I need to move 6 places to the left, and this now shows me that I have a 0.5 micromolar, a 0.05 micromolar is this very small number of moles. I need to now convert this into scientific notation. So this 0.05 micromolar would equal 5 times 10 to the negative 8 moles. If I take the negative log of that using my calculator, I get a pH of 7.3. I hope that helps you. In fact, let's just do that again right now. I take the negative log of 5 times 10 to the negative 8, close my parentheses, and I get 7.30. All right, I hope you have a good day.